I think clearly a lot of this is up there on Linux Foundation Edge. There's different flavors. The original Java version and the C client is out there. Red Hat, as you're well aware of, implementation in Rust. VinCSS, a Vietnamese company, have created their own implementation. So there are several, and I'm sure that's not the only ones, but few that jump to mind. Clearly, if you go up and look in GitHub, you can see the C and Java repositories. And then recently, there's been the addition of the work done primarily by Intel to add the Go implementations, which are up there. So, Brad, why don't you talk a little bit about the Go repositories and kind of take the ball from there?
Yeah, I don't think I'm going to be too long with this, but the only thing I want you to point out on this slide, so the Go FDO project was originally started as meaning to be like a general purpose library for people developing Go solutions to use. The Go FDO library contained an examples directory where you could actually build a server and client within that, and that's kind of what I'm going to be showing very briefly today. But the Go FDO client and Go FDO server projects below are kind of taking those client and server pieces and breaking them out from the Go FDO project. Again, it was supposed to be a library, and showing how the library can be used in more freestanding apps rather than. So you can, if you wanted to play with this, I'm going to be playing with Go FDO directly, the stuff in there. It's maybe a little bit of an easier way, but the Go FDO client server is supposed to be a breakout of those. Okay, yeah, next slide. So I just wanted to talk very briefly on these different implementations and just more so the logistics behind them. And you guys probably already know. So Go is an awesome way to build user space portable applications for platforms and environments which support the Go runtime. So Linux, Windows, I don't know what else. Easy to build on x86 ARM, 32-bit, 64-bit, whatever. So Go and the Go implementation also contains full rendezvous, full onboarding service, full client. So Go is definitely my short way to go on those. The C is much more an older support original. It's client only, and the advantage of C, which I'll show you shortly, is obviously it's C. It can be built, cross-portably. You can obviously compile C down to a number of different environments, embedded environments, whatever. We'll show you in a second. The C actually has, as simple as it is in being able to compile down to any environment, there's a lot of dependencies on that could make C less than advantageous way to start targeting this towards other environments. And by other environments, I mean things like EFI and U-boot. I also saw Tiano Core, some references to that in the talks. So anyways, in that kind of BIOS environment. So Rust, I have very little experience in. Rust is obviously meant to be like a memory safe, low level compile version language similar to C. Don't know much about Rust. It obviously came to life from Red Hat. Not 100% sure on where that's going in terms of support or whatever. But so long story short, if I had to go with something like U-boot today, I would want to go with a Rust implementation. Go isn't going to have the runtime that would require. C would be an alternative. But anyways, those are like obviously the trade-offs and logistics and looking at a client implementation in the different languages. So you're going to say something, Richard?
Yeah, I was just going to say, Peter in a prior life, knows very well the history of the Rust implementation.
Okay. Yep.
Rust implementation is a full stack. So client, rendezvous server, onboarding server, compliant and tested to the 1.1 spec. It has primarily been tested on Linux, but there's no reason the client shouldn't run on M class or as be, portable to a UEFI app or various other bits and pieces. The onboarding server side, it's a little lacking in that it needs sort of the ability to do backend management APIs and things like that. So it could plug into other management platforms. But, overall it is a complete, platform essentially, or complete implementation.
Okay, Brad, did you want to show some stuff?
Yeah, so I'll just, let me hit the share button here. And I'm just I'm not gonna spend a lot of time because code demos on debug screens are kind of boring if you haven't written them. Right. So, long story short, the Go FDO version has a README that describes basically how to build and run everything. It's pretty straightforward. It is entirely a native Go implementation. There's no CGO encumbrances or anything. There is one library that it pulls in, but it's I think the Seaborn Cozy library. But that's done just as Git submodule. It's pure Go. So unsurprisingly, so I'm gonna do like if I just so there's a database that the server itself uses to store credentials and stuff like that. This is just a very quick demo of it. You bring up the database, and so my left side is sort of like my server, and my right side is the client. So I'm just running the server, and it's actually in debug mode on this side. I'm running the client on this side, requesting to do a device initialization. After I do that, debug is really boring. Device initialization is done on this, and when that is done, it winds up creating this cred.bin file, and the cred.bin file is where it stores so all the stuff that Jeff was talking about earlier that would effectively go in the TPM, the keys, the HMAC secret, some of that, the credential stuff that needs to be stored on the device. And once that is stored on the device, I can then just go, and I'm going to take the DI flags out of here. I can just run client. And when I do, lo and behold, it does everything. There's some markers you can see. So that actually did the full TO0, TO1, TO2. And I think in this debug, you can probably see, for example, the FSIMs were running in here, but another terrific debug outputs demo, FDO is done. So anyways, I did want to point out here that so for example, let's see, the again, this command here is running that the client code or the server code that's inside this Go FDO library. And as with any or with most Go commands, it is static. There are no dependencies on it. This executable right here is 17 meg. So this executable wasn't actually running because I was running in Go test mode. But if I do a file on that, this is another one that I built. So this is actually an ARM64 version that I built. It is super easy. I can do an ARM build with this command. So it cross compiles very easily between ARM, ARM64, and x86. The size on that one, it's actually coming in at about 15 megabytes. I say this because at least Dell, some of the stuff that I'll get into, very sensitive on memory footprint, but those can actually be pared down a little bit because that 15 meg executable, so that's the ARM 32-bit one, but that contains DI, server, client, and the full library. So to just say, oh, I only want to run client on here, I've personally, in very, very like 2 seconds worth of clipping out some code, got that down to about 12 megabytes. So again, let's say a 12, 15 megabyte static executable. This is a Raspberry Pi I have here. I don't even know. I've run both the 64-bit and the 32-bit versions on here. But I can I'll run the 32-bit version in debug. And actually, so it failed. The only reason why it failed is because I already ran it on here. So it already, like Jeff said, it'll swap out the credentials. And I already run it, so it swapped out the credentials. But the long story short here is that you can build these ARM variants to run, and it is just as ubiquitous on x86. So yeah, that's good.
Thank you.
So that failure was a feature. Good.
The failure was literally a feature. The only other thing I want to show here is, so this is the C version. And the C version, I can also run this, and it is going to fail if I do. And the reason that it's going to fail is because, as we said before, it's going to fail in the device initialization phase. And the reason being, like we said, DI is not a standardized protocol. So this worked a couple weeks ago, but somebody added or changed like one of the fields that they wanted to send. So this is actually talking from the C implementation to the Go implementation. Somebody changed one of these implementations to add or remove a field that was specified in the DI data, and it broke that, and I couldn't get it fixed late last night. So can't actually show it running, but that's at least an attempt to run DI, and kind of a statement that it's pretty ubiquitous. The other thing
is that you're packing data into some of the fields that are being transmitted with DI. DI itself is
oh yeah.
Right?
Yeah.
So
Let's take a break, maybe, Brad, and just see if there's any questions. If not, maybe we can.
Okay, I just have only 30 seconds left to go. So let me just finish with this. Yeah. But anyways, yeah, to Jeff's point, these are the fields that are packed into that DI. These are ones that were removed recently. There's a different set of fields on the C implementation, which is why it didn't work. And the last little thing I wanted to point out only was that the build Linux. So if you look at, this is the C implementation.
Oh, sorry. Keep going.
So,
don't worry.
Sorry, the C implementation, unlike what we're saying, 15 megabytes on the Go implementation, the C implementation is only 1.6 megabytes. Wow, a lot smaller. So you might think that, on the get-go, this would be a lot easier to run on an embedded platform. However, the C implementation, has quite a bit of shared library requirements. I didn't even know what some of the, there's obviously a lot of crypto stuff. There's some web-based stuff like curl or whatever. There's a lot of KRB5 stuff. I don't even know why exactly that's there, other than some Kerberos components. So as we might think, well, it would be much easier to take C and port that over to a firmware environment. There are so many dependencies on the C environment of other third-party libraries that might not be available on that, again, that might be a reason to look at the Rust environment first. But anyways, that's kind of the C environment's really easy. Again, there's a README file. There's 2 external libraries that you need to pull in. Well, I think one is a Cozy or Cbor library, and the other is some sort of packing library. But other than that, there's just README files on GitHub, and they're pretty simple and low friction. But that's sort of my overview of the code bases.
Okay, so Joachim and Peter, any comments, or are we good? I just don't want to belabor this.
This is good. Thanks for the demo. The one thing that I was thinking about initially when we actually reached out to you and started talking about this is that we heard about your implementation and the Red Hat Rust implementation. And the DNA of Linar is typically reduce fragmentation. And that was kind of my first thinking. Are we having fragmentation here? Could you, for example, run the Go-based client together with the Rust-based server? API versus API and so on. That's what I'm thinking about.
So when Red Hat started doing this, there was no Go implementation. We were there was the C client Java server implementation, and we didn't want to deal with C on the client side. We didn't want to deal with Java on the server side. And so Patrick wrote it in Rust, because if it's going to be new code and it's low level edge, it should probably be written in Rust. We did some interoperability testing, and in actual fact, one of the first interop testing we did, it failed, and we looked at it, and it was the spec was inconclusive, and both sides had implemented the spec wrong. So the spec was clarified, and both sides fixed their implementation. So I don't there's no reason it shouldn't be compatible.
Okay, well, that's good. That was my concern. If we have you can't use
and then you get into so FSIMs are optional ways of extending, and so Red Hat implemented a bunch of FSIMs for their platform, and we were working with FIDO to deal with, like, you know, there was a user ad one where it's like there should be a generic supported across everything, like add a local user. And we were looking at, I forget the name of the protocol that deals with like issuing of client-side certificates, but there is a standardized protocol. So it was like, we should have a implementation for that. And we had an FSIM that like essentially copied files and an FSIM that ran commands. And so things like that will end up being like Linux specific or whatever. But the way FSIMs work, you should be able to essentially negotiate client server which supports which are standard and what have you. So it shouldn't make any difference. Because, like, you know, adding a user on a microcontroller probably doesn't make any sense. And so there'll be like implementation specific stuff, but as of like 1.1 spec, they were cross referenceable.
Perfect. I'm happy.
Right.
There is also a set of FIDO did bring out a set of standard FSIMs as a base.
Yeah,
Although everything Peter said is correct, because you can still add your own.
yeah, and I seem to remember Red Hat works with FIDO on those, right?
Well, FIDO doesn't have implementations, but we created a standard set of FSIMs so that the implementations could have a base set, and
Yeah.
at least if all you needed to do was get a file down and run it, there would be a standard way to do it.